Yo. Yo. All right. Talking about scatter plots, line of best fit. It's our last section of topic 3. So a lot of vocabulary, but we'll notice that it's pretty, a lot of key terms, but we'll notice that it's pretty self-explanatory, especially once we start talking about scatter plots and what the line of best fit looks like, and what negative association looks like, what positive association looks like, or negative correlation or positive correlation, which are actually really the same thing. So get your definitions down, and we'll talk about it as we go. So a scatter plot, okay, a scatter plot is a collection of data points on a graph, on a coordinate plane. So it is a collection of data points on a coordinate plane. Now with scatter plots though, a lot of times though, it's not going to make an exactly perfect straight line. It's not going to happen because the data might be different all the time, but it might still follow a certain trend. So here is an example of a scatter plot, the temperature after sunrise. Okay, so what we did is we took data points, what the temperature was after sunrise, and depending on the hours after, how many hours after sunrise, of what the temperature was. So after sunrise, in the morning, right after sunrise, the temperature was at its lowest. But as the longer the time went after sunrise, the temperature started slowly increasing. Okay, maybe not at the exact same rate, but it was slowly increasing. And then same thing here, temperature after sunset, it started going down. It was decreasing. So here is a scatter plot. It's got all my data points. So what we want to describe is the type of relationship we have between the amount of hours after sunrise and the temperature. Well, if we notice, the temperature increases as the amount of hours after the sunrise increased on this particular scatter plot. So what this means is this scatter plot has a positive correlation. The reason why is it's trending upwards. It's going up. Okay? The direction of this data is moving upwards. Okay? As my x values increase, so do my y. That means as a positive correlation. Positive trend means we're going up. Means that if I were to draw a line through it, it's going to have a positive slope. So if this is a positive correlation or positive association, then this would be a negative association. If I drew a line that tried to go through the data, it shows the direction is going downwards. Because as the further we go after sunset, the further down the temperature goes. So the temperature is decreasing to give it a negative correlation. Finally, if we look here, hours after sunset and rainfall after sunset. So what is the relationship between the hours after sunset and the amount of rain? So hours after sunset, so this is after the sun goes down, how much does it rain? And if you notice, the points are kind of all over the place. This is when there's no correlation or no association. Okay, and the reason why is because the rain and the time of day have nothing to do with each other. Okay, we know that after the sun comes up, it's going to get hotter in the day because the sun's up. And when the sun goes down, it's going to get colder because the sun has gone down, and now we don't have the heat from the sun. But the sun has no impact on when it rains. Those are two things that have nothing to do with one another. So therefore, there's no association because the data is all over the place. There's no specific trend. It's not slowly going up. It's not going down. It's kind of scattered all over the place. So that means there's no correlation between the two. So no correlation meaning that the rain and the hours after the sunset have nothing to do with one another. Okay. Now what we want to do is we would model these relationships with trend lines. So here's what a trend line is. And I kind of already drew, we kind of already mentioned it a little bit. We want to draw a line that shows the direction of the data. Now this trend line, it's going to be a straight line. So it is impossible for me to connect all of these points with a straight line. Whoops, wrong one. However, what I can do is I can draw a line called a trend line, or also known as a line of best fit. I can draw a line that represents a lot of the data, that represents the majority of the data, that shows the direction of the data. So like if I drew a line like right here, I have some data points below, some data points above, some data points below, but this goes along the data and it shows the direction of the data. This would be an example of a good trend line because this shows me the way the data is moving. Okay, so this would be a way to model this data. Is I can model with the trend line and then I can write the equation of my trend line. So to write the equation of my trend line, I need a y-intercept. So it looks like I started here at 60. And then I got to find a perfect point that my line goes through. Not a perfect data point. I got to find a perfect point of my line. So it looks like we're really close to a perfect point right here. So this would work. So my rise from here to here, this graph is counting by 2s. So that means I'm going up 2. My run from here to here, it's counting by 1s, so I'm actually going over 2. So my trend line is just 1 over 1. Okay. So my y-intercept starts at 60. So what my model of this data is 1 over 1. Ooh, that is not what I just said. I don't know how I wrote that down and said something totally different. 1 over 1x, and I start at 60 degrees. That means after the sunrise, at sunrise, we're at 60 degrees, and then it goes up 1 degree every hour. And that's not guaranteed, but that's about the average of the data based on that trend. Okay, try drawing a trend line for this one and see if you can write the equation of that trend line and see if it's somewhere close to mine. So pause if you haven't done so already. Okay, so my trend line here, I'm going to go to, let's go right about there. Okay, so again, I have some data above, right on it, a little bit below. So this really shows the direction of the data. Now, one thing you'll notice is people's trend lines, like your trend line might be different than your neighbor's, which is okay. Okay, it's just the fact that they should be somewhat relatively close. So like for this one, if you guys drew your own trend line, maybe you didn't have 1x, maybe you had 1.5. Okay, it's going to be close, so we should still have somewhere around 60. This trend line, we should start anywhere between 72 and 70. Okay, you could have started a little bit higher, a little bit lower. I started right in the middle, so my start point was at 71. Then I need to find the slope of that. And the hardest part is really going to be finding a perfect point. And when you draw it, make sure we can also make sure that we find a perfect point. We can make sure that we go through a perfect point just to make our trend line a little bit easier to write the equation. The closest thing to a perfect point that I have looks like it's right here. Okay. So that means from 71, and I'm going all the way down, because this isn't even a perfect point, but I know that this is when y is 71 and x is 0. So from 71 down to this point right here, this is 62. So from 71 to 62, I go down 9. So my rise is 9. I'm going to put negative. And then I go from 0 to 7 hours. So that's negative 9 over 7x. Now this would be one of those examples where it does help to convert it to a decimal just for the context of the problem. Because what I'm saying is the temperature is going down by 9 over 7 degrees per hour. But that doesn't really give me much information. So I might want to actually do 9 divided by 7. And I got 1.29. I rounded that to the nearest hundredth. So I can say that my temperature is going down about 1.29 degrees every hour. And I'm starting at 71 when the sun goes down. So you should add somewhere around negative 1.3. Maybe you had 1.2. Maybe you had 1.5. Okay, 1.4. Somewhere in that general ballpark, though. And we should add somewhere around starting at 71. Okay. So scatter plot, we draw a line that goes with the direction of the data. That's the trend line, or also known as a line of best fit. And then we write the equation of that line. So go ahead and answer these two problems on your own. Okay, so for number one, we have a positive association, or positive association and positive correlation are the same thing, really. Okay, so that's positive. And this one, we are going down. So this one would be negative. Okay, now I want to describe each type of correlation each scatter plot shows. Draw a trend line that models each data set and find the equation of that trend line. So I'm going to draw my trend lines. Actually, I want you guys to draw your trend lines, write your equation, see how you do. All right. Whoops, I'm actually going to pause it, then I can just make this go faster for you. Okay, so for 3, here's my trend line. Here's my equation. It's positive. Okay, that's the type of correlation. It's a positive correlation. I started at 50. So one thing I wanted to point out here is be careful. You guys see how there's like this break here in the graph, how we have that line? And it shows it's because we started from 0, we went straight to 50, and then we started counting by 5s. So what's that saying is that we didn't want to show from 50 to 0 counting by 5s because that's a lot of wasted space and it makes it hard to see the whole graph. So this is your way of saying we're skipping a section of the graph to go straight to 50, but then we're only going to count by 5s. So it's just saying part of the graph is missing because there's no point in showing it because there's nothing there, just so you know. So I started here at 50, and then I went to 65 over 3. That's the next point of my trend line. So let's see here. We were going up 5 degrees every hour, and we started at 50. So you should have somewhere around there. Negative correlation over here. I started my trend line up here at the top at 9. I went down, and then from there, I found my point here at 7. Now, one thing I also want to point out, we had a break in the graph on both of these, right? So I can't just count from 0 to 7 and say that that's 6, because if I actually counted my slope, the run is really 1, 2, 3, and it's counting by 1/2. But really, I'm going from 0, and then my x is 7, so that's going up 7. If I counted and I didn't recognize a change in the graph, it wouldn't have worked this way. I wouldn't have had an accurate slope. So I go from 0 to 7, which is a change of 7. Okay. So slope was negative 0.86, and then I started at 9, so there's my equation. What we do with these trend lines is we use these equations to make predictions. So for item number 3, for the trend line in item number 3, what would you expect the temperature to be after 2 hours? So I go from 2 hours, look at my graph, that'd be right here is where the line is on my graph at 2 hours. Looks like it's about 58 degrees. Okay, maybe even 60. It's close to it. But what I can use my equation to plug in 2 for x, because x represents hours, and then I can solve from there. And I got 60. Okay, so that means that after 2 hours, the temperature would be 60 degrees. And I used my line of best fit, my equation to do that. And I could have looked at my graph. I would have had about 58, 59 if I looked just at my graph. But with my equation that I came up with, I got 60. Okay, at the cost of $6.50, again, this is the cost in dollars. So now for number 6, I can plug that in. This is going down 86 cents, okay, for sales. So 86.86 million, really. Okay, and so, because this is in millions. But I can plug in $6.50 for X here. So I can do negative 0.86 times 650 plus 9. You can also look here, 650, and my trend line hits 650 right here. And it's right below 4, so I know it's going to be maybe about 3.8 or so. And that would be a great answer. Or I could actually solve the problem, and I could do 0.86 times $6.50. That gives me $5.59 plus 9. I'm sorry, I should have been minus 9. Whoops, I forgot about my negative. Gradius messed up. I'm just doing this on my calculator right now. I apologize. I gotta do 9 minus 559. Sorry, I'm having technical. There we go. $3.41. Okay, so my line was somewhat close to that. And there we have it. Okay. All right. So that's all I got for you guys. Okay, and no independent practice. So we'll practice this in class. We'll draw our trend lines, we'll make predictions using them, and that's it. So if you guys have any questions, let me know. Gradius out.